Welcome to my 13th tutoring session in A-level chemistry. In this video, I'll explain how to calculate the effective nuclear charge of an element in the periodic table. In order to understand the concept of effective nuclear charge, one should be familiar with the meaning of valence and core electrons. Let me explain the valence and core electrons with respect to calcium atom. The nucleus of calcium atom contains 20 positively charged protons with the electrons arranged or distributed around the nucleus of the calcium atom in their respective shells or energy levels. The first shell contains 2 electrons. Second shell contains 8 electrons. Third shell contains 8 electrons. The fourth shell contains only 2 electrons. I have highlighted the valence electrons in blue and the core electrons in red. Now the valence electrons are those electrons present in the outermost shell, also called as the valence shell. And these valence electrons are far from the nucleus and easy to remove. So why is that valence electrons are easy to remove? Because as they are far from the nucleus, they experience a weak attractive force towards the positively charged protons present in the nucleus of the atom, and thereby less amount of energy is required to remove the valence electrons. Now, what about core electrons? Core electrons are those electrons that are present in the inner shells, and these core electrons are closer to the nucleus and difficult to remove. Why is that core electrons are difficult to remove? Because the core electrons experience a strong attractive force towards the positively charged protons present in the nucleus, and as a result, a large amount of energy is required to remove the core electrons. In addition, core electrons also contribute to shielding, and that is why it's also called as shielding electrons. So how core electrons contribute to shielding? The core electrons that are present in the inner shells, they partially block or reduce the electrostatic force of attraction between the positively charged protons present in the nucleus and the valence electrons, and thereby they contribute to shielding. Now, most importantly, core electrons reduce the effective nuclear charge. So what is effective nuclear charge? Effective nuclear charge is the electrostatic force of attraction between the positively charged protons and the valence electrons. We can also define effective nuclear charge as the net positive charge experienced by the electron in a multi-electron atom. Now each new shell or energy level with core electron, it adds more shielding between the outer valence electrons and the nuclear protons, leading to weaker attraction between them. Remember, the effective nuclear charge represents the net positive charge experienced by an electron in an atom. Let me explain the shielding in group 2 elements, beryllium, magnesium and calcium. There is less shielding in case of beryllium, moderate shielding in magnesium, while high shielding in case of calcium. Why is that? The reason is beryllium has only one shell with core electrons, while magnesium has 2 shells with core electrons, while calcium has 3 shells with core electrons. So as the number of shells increases, the number of core electrons also increase, and thereby the shielding also increases. So as the number of energy levels or shells increase, the number of core electrons increase, and this leads to increase in shielding, and as a result, the effective nuclear charge is reduced and the attraction between the positively charged protons present in the nucleus and the valence electron is also drastically reduced. Now beryllium has only 2 core electrons, while magnesium has 10 core electrons, while calcium has 18 core electrons. As the number of shells and core electrons increase, the shielding also gradually increase. Now the effective nuclear charge can be calculated using the formula Z effective is equal to atomic number minus number of core electrons. Let's start applying the formula to the elements chlorine and calcium. The core electrons are highlighted in red, while the blue electrons, the valence electrons are highlighted in blue. So I highlighted in order to make it easier for the viewers to distinguish the core electrons from the valence electrons. Now the effective nuclear charge is calculated using the formula atomic number minus number of core electrons. So in case of chlorine atom, now applying the formula. So what is the atomic number of chlorine? It is 17. What about the number of core electrons? So 2 core electrons in the first shell and 8 core electrons in the second shell. Total of 10 core electrons. Now if you are finding it difficult to count the number of core electrons from the electron diagram, you can always follow the electronic configuration for the given element. Now here in case of chlorine, I have highlighted the electronic configuration in red, that part of the electron configuration referring to the core electrons. So if finding it difficult to count the number of core electrons from the diagram, you can always refer the electronic configuration. So it's quite easier to calculate the number of core electrons from the electronic configuration of the given element. So the Z effective for chlorine is +7. And what about calcium? Calcium, atomic number of calcium is 20. It has 18 core electrons, 2 in the first shell, 8 in the second shell, and 8 in the third shell. You sum up, you get a value of 18. That is the number of core electrons. And Z effective will be 20 minus 18 plus 2. Now, sodium element, it's a group 1 element with 1 valence electron and Z effective value of +1. Magnesium is a group 2 element with 2 valence electrons and Z effective value of +2. Aluminium is a group 3 element with 3 valence electrons and Z effective value of +3. Silicon is a group 4 element with 4 valence electrons and Z effective value of +4. Phosphorus is a group 5 element with 5 valence electrons and Z effective value of +5. Sulfur is a group 6 element with 6 valence electrons and Z effective value of +6. Chlorine is a group 7 element with 7 valence electrons and Z effective value of +7. And argon, being a noble gas with the most stable electronic configuration, it's a group 0 element with 8 valence electrons. Its outermost shell is completely full with Z effective value of +8. Now there is a strong correlation between the group number of the element, number of valence electrons, and the Z effective value. So the group number of the element will be same as the number of valence electrons as well as the Z effective value of that particular element. For example, sodium is a group 1 element. It has 1 valence electron and Z effective value of 1. So if you know any one of these three, so if you know the group to which the element belongs, its valence electron will be the same as well as the Z effective value. So for sodium element, it's a group 1 element. So its valence electron will be 1 and Z effective value will be 1. So what about aluminium? So aluminium is a group 3 element with 3 valence electrons and Z effective value of 3. So if you know the valence electrons, you can find the group to which it belongs and the Z effective value. For example, if I say the Z effective value of silicon is 1, and if I ask you to find out the group and the number of valence electrons, it will be the same. So the given value is Z effective value of silicon. What I given is 1. So what about the group? It will belong to group 1. Sorry, it will belong to group 4. And number of valence electrons will be 4. And suppose if I give the valence electrons of a element, say for example, I given the valence electron for chlorine. Say the given value is for chlorine is 7 valence electrons. So what will be the group it belongs? It will be the same. So given is 7 valence electrons, so it will belong to group 7, and its Z effective value will be 7. So if you know any one of these three, you can find the other two easily. So if you are given the group to which the element belongs, you can find out the valence electrons and its Z effective value. So there is a strong correlation between the group number of the element to that of its valence electrons and its Z effective value. Now the effective nuclear charge increases as you move from left to right in the periodic table. Now, as already mentioned, there's a strong correlation between the group to which the element belongs and its Z effective value, as well as its valence electrons. For example, lithium and sodium are group 1 elements with Z effective value of +1. Beryllium and magnesium are group 2 elements with Z effective value of +2. Boron and aluminium are group 3 elements with Z effective value of +3. Carbon and silicon are group 4 elements with Z effective value of +4. Nitrogen and phosphorus are group 5 elements with Z effective value of +5. Oxygen and sulfur are group 6 elements with Z effective value of 6. And halogens are group 7 elements with Z effective value of +7. So there is a strong correlation between the group number of the element to its valence electrons and the Z effective value. For example, let us consider the case of halogens. So if I say halogens belong to group 7, so how will you find its valence electron and its Z effective value? It will be one and the same, because the what is given to you, it's a group that is given to which it belongs, the halogens. So I have given that halogens belong to group 7, and I have asked you to find out the number of valence electrons and the Z effective value. So group number will be same as that of the valence electrons and the Z effective value. So since the halogens belong to group 7, it will be having 7 valence electrons in the outermost shell, and its Z effective value will be 7. So this is the most easiest way of finding out the group number of the element, valence electrons, as well as the Z effective for the given element. Now some homework questions relating to the effective nuclear charge. If you are facing any difficulty in finding answers to any of these 4 questions, you can comment me and I'll get back to you. Don't forget to subscribe my channel, share and like my videos. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.